Hi everyone and welcome to this new video. In this video I continue my Linux Privilege Escalation series, and in particular we are doing this small section on enumeration. In the previous video I discussed how to do a full system enumeration. In this video instead I will focus on the aspect of cronjob enumeration. So in this video we will see an example of Linux cronjob enumeration. I will discuss what is a cronjob, what are cronjobs. I will discuss how we can configure them in a Linux system, how we can enumerate them, and then I will show a practical exploitation example where we go from enumeration to exploitation with a given out-of-the-box machine. It is the bashed machine, which I already made a full walkthrough. In this video we will just focus on the cronjob enumeration aspects. As always, I hope the video is interesting and you get something out of it. If you do, please leave some feedback, subscribe to the channel, and share this video with like-minded people so you can help me grow. So we can start with the video. I hope you enjoy it. First things first, what is a cronjob? Well, in Linux-based systems, a cronjob is essentially a command that is executed with a specific time rule. So when you see the word cronjob, just think command like a bash command, a script, a program, any sort of action that you can do on the operating system, however, that is executed based on a time rule. This means essentially periodic, every minute or every 5 minutes or every day, or you can get even more complex configuration like every 5th day of the month execute this task at 12 AM. Things of the sort. Now, these commands are typically used to manage a running environment with tasks that need to be repeated every once in a while, such as backups, certificate renewals. So here we're talking about the TLS certificates. So in this case, it's the TLS X.509 certificates that has to be renewed because otherwise they expire, or removing temporary junk files, restarting the processes, and so on and so forth. So in running a complex system that is used for various tasks, for various things, you need to do periodic activities, and Linux offers the cronjob utility to take care of that. Now, understanding what kind of cronjobs are being executed in a system can be extremely useful, especially if the cronjob configuration is vulnerable. Once again, in the previous video we discussed why enumeration is important, and we said that enumeration is the process of painting the picture that represents the system. Once you have the picture, then you can understand the vulnerabilities, and once you understand the vulnerabilities, then you can exploit the system to obtain what you need to obtain. So that's the idea. In terms of cronjob, some configuration can be vulnerable, so once we enumerate them, then we can exploit them to obtain, for example, privilege escalation. Now, before discussing how we can enumerate them, it is useful to discuss how we can configure them and how configuration works. As always, in the context of computer security and offensive security, the general idea is that to understand how you can obtain information and how you can attack a system, first you need foundational knowledge on that given system. In this case, we are talking about cronjobs. Therefore, to enumerate and exploit cronjobs, we first need to understand how we can configure them. Only then we can understand how to enumerate and exploit. So, how can we configure cronjobs? Now, to list out the cronjob configure for your particular user, you can execute the command crontab-l. This means that different users can have different cronjob configuration. Now consider this Kali box. So this is the Kali Linux that I'm attached to out-of-the-box, and here I can do a simple crontab-l. And notice it says no crontab for the user Leo. So right now I have no cronjobs configured for me. This is the idea. Now to edit the cronjob configuration instead, you can use the crontab-e. Crontab-e. And then it opens an editor. In this case, it's a vanilla configured Emacs because this is what I use. So this is the idea. This file, this crontab file, we can edit this file. After we save this file, the cron daemon will be reconfigured to take into account this new configuration. Now, as you can see, it says edit this file to introduce task to be run by cron. Each task to run has to be defined through a single line, indicating with different fields when the task will be run and what command to run for the task. So this means that we will have different lines here, and each line is representing a specific cron job configuration, where each line specifies some timing rule that specify when the command will be executed and the command to actually execute. To define the time, you can provide concrete values for minute, hour, day of month, and day of week, or use the wildcard in these fields for any. So what does it mean? Essentially, it means that a typical cron job entry will look as follows. So here we have 5 numbers, 1, 5, 1, 2, 3, 4, and 5. And eventually, some of these 5 numbers can also be this wildcard character, this star character. And then we have a command. Other times we might have this thing with the user. So like in this case we don't need the user because the user is already assumed. Other times we might have the same thing, but here we specify the user to run this command with. So there are different configurations. When we edit with cronjob-e, we do not need to do that. So it's the user does not need to be specified. So the various numbers, the 5 numbers at the start, taken together are used to specify the timing information. That is, are used to specify when exactly, time-wise, the command has to be executed. Now specifically we have the minute, hour, day of month, and day of the week. So here there is a small typo, day of the week. For example, to execute a command on the 15th of February, so 15th of February at 9 AM, you can use the following rule. So this 09 specifies the minute and the hour on which to execute. So anytime we have minute 0 and hour 9, we execute this command. This means 9 AM. The third number is the day of the month, so the 15th of the month. So when the day is the 15th of the month, we execute the command. And finally, the second is the month. So this fourth number is a month, which is February, because 1 stands for January and 2 stands for February. And this fifth wildcard, it means that no matter when the 15th of February comes, if it's a Monday, a Wednesday, a Friday, a Saturday, a Sunday, it doesn't matter the specific day of the week. We will execute it regardless of the day of the week. For example, let's try to configure a very simple cron job here. We can say wildcard, wildcard, wildcard. So we have gonna be 5. So this is 3, 4, and 5. The command is a simple echo. We say hello world, and then we pipe this into TMP test. We save this, we close the editor, and now after the new minute, so in a bit, so let's go into temp. There is no test file now. Then notice this. Now after the minute has passed, notice this test file. If we check its creation date, it was in the 35, so 16:35 minute. And then if we check the content, it's hello world. If we remove it and we wait another minute, it will be recreated again, because now the cron tab-L, look at this, now we have a cron tab, we have a specific job configured, and this job is saying to echo hello world into this file. So in a bit it's gonna be the new minute, it's gonna reappear again. So that's essentially the general idea. And so the crontab method is a way in which you can configure cronjob for specific users, such as the Leo user. Now there are other ways, however, that you can specify cronjobs without using the crontab, and this is by writing into specific configuration directories and files. Now let's get into root. So we're gonna get into root, so now we are root, and if we check the contents of the file etc crontab, we see that we have essentially this content. We can open it with Emacs, etc crontab. We can open it with Emacs, and here we have general cronjobs. Now the syntax used is exactly the same. The only definition is that in this case, other than the 5 like wildcards, 1, 2, 3, 4, and 5, we also need to specify the username before the command. This is because while the cron tab was already configured for the specific user, user Leo, user root, so this information was already implied, so you did not have to specify it explicitly. In this case, instead, this file is general, it's for any user of the system, and therefore we must specify the username that will run this command. For example, the root user to run these commands, and so on and so forth. Now there are other directories, like we have etc, cron, and then we have cronD, cron daily, cron hourly, cron monthly, cron weekly, cron early. So the idea is that in each of these directories, we have specific scripts that will execute in that given, for every given day. So in a new day, you will execute this script, like to clean stuff and so on and so forth. So this is essentially the idea. So like this is John, and here also is another directory, cron.d, where you can specify the cron jobs. And also notice this difference. While we are in this directory, here we specify cron jobs with the typical cronjob configuration, while if we go into cron daily, here we specify directly the script to execute. So these scripts they inherit the rule, the time rule, based on the directory. If they are present in cron daily, they will be executed once per day. If they are present in cron weekly, they will be executed once per week. So in this case, we do not need to specify the cron job rule because it is already implied by the directory, sort of. So this is already implied by the directory. And this is essentially the general idea when it comes to cronjob configuration. Now at this point, we can go into the more offensive side of cronjobs. We've seen the system side, why they are used and how they can be configured. Let's try now to tackle two more interesting questions: how they can be enumerated, and then I will show a practical exploitation example. So at this point, we can start to understand how can we enumerate cron jobs. And I want to understand if there are cron jobs executing in this machine. How exactly can I do that? What facilities can I use that will help me to understand if there are cron jobs being executed right now? Because it's not that easy to understand, given that sometimes these commands are really fast to execute. So how can we do it? Well, the idea is that to enumerate cronjob in Linux, we can use a tool called PSPY. And here I put the GitHub link that you can see here. This PSPY by Dominic Breuker monitor Linux processes without root permission. So the key idea of this tool is that it does not require root privileges. And this makes sense because if we needed root privileges, then this tool couldn't be used to do privilege escalation. Since the tool does not require root privileges, it makes sense to be used in a privilege escalation scenario. So PSPY is a command line tool designed to snoop on processes without need for root permissions. It allows you to see commands run by other users, cron jobs, etc. as they execute. Great for enumeration of Linux system in CTFs, also great to demonstrate your colleagues why passing secrets as arguments to the command line is a bad idea. The tool gathers the info from procfs scans, iNotify watchers placed on selected parts of the file system, triggers these scans to catch short-lived processes. So essentially, the idea is that this tool uses a specific file system which is called the /proc file system, and this file system is generated by the Linux kernel during its execution. The Linux kernel uses this file system to contain information, dynamic information that reflects the current state of the processes being run. This is why it's called /proc. And so the idea is that this tool utilizes this information in order to obtain information regarding currently executing processes, which include, of course, cronjob processes. So essentially, you go into the system, you go into /proc, and notice here you have a bunch of different files. Here you have files that have numeric values in the first section of the directory, here, essentially. And then in the other section, you have other stuff, so like this one, always with an ID, with a number, and then these other are more general of the overall system. So if we zoom in into any given number, like let's say CD096, we have a bunch of information for this ID. Now, what is this ID? It is the ID of the process. Like for example, if you do a PSaux and the second column is the PID, so if you go into 906, so this one, 906, this is the SSH agent X session manager. So if we go, for example, we take the CMD line file, this CMD line is exactly user bin SSH agent X session management. So these files are actually not really normal files as in your typical files. These files are created by the kernel and they are handled by the kernel. When you ask the content, the kernel is executed and it reads from memory the content of this file. So this is a in-memory file system, the /proc file system, which is handled by the Linux kernel. And the idea is that the PSPY tool uses this file system to obtain information about currently executing cron jobs. When a cron job executes, a new entry in this file system is created, and so the tool understands that. And then there are, of course, optimization to make sure that the process of looking for new directories and files is efficient and doesn't slow down the system and the usage of the tool. So the first thing you need to do if you want to use it is you need to understand the underlying hardware architecture that your CPU is running on. Specifically, if it is a 32-bit CPU or a 64-bit CPU. And I showed how to do this in the previous video. We can simply do uname. We can simply do uname R and it uname dash A. And here we have all the information. Specifically, we're running on x86_64, meaning it is a 64-bit architecture. And so we can download the 64-bit version of the tool. So we can use wget to download the tool. We can do wget, and here is the URL essentially. So github.com. And so at this URL, we can download the latest version. Of course, this command should be executed on a directory in which we can write. So for example, we can do into tmp, the temporary directory, and then we can do the wget command. We wait a bit. So after we have downloaded the tool, we can check out its characteristic with the file command. Notice that it is an ELF 64-bit executable, and specifically notice that it is statically linked. It means that all the dependencies and all the libraries are contained within the executable, and there is no need for external libraries, like for the glibc library and stuff like that. If we do an LDDD, which tells us the dynamic libraries, it says, look, this is not a dynamic executable. I have no dependencies on the current file system. This is extremely useful when it comes to exploitation, because in a remote system, you never know if you have the right versions of the library. And also, this is why this executable is like 3 megabytes, which is not that light. There is also another version, which is the small version. So the small version is dynamically linked, because the idea is that it's small, the payload is small, however it requires external library, so it might not work if you download it on a host that doesn't have those binaries. So after we download the tool, we can just make it executable as follows. And so at this point, the only thing that we need is just to execute it essentially. So we do pspy./pspy. And then here it's gonna start to analyze the proc file system, and it's gonna give us like files that are executed in the moment essentially. So like here, for example, we can see that it executes a lot this script xfce4 panel genmon vpn ep.sh. So this script. And then like in a system, in a CTF, you just wait until you see something suspicious. And so that's the idea. So it's the output that we will see. Now, in terms of cronjob exploitation, I want to give a practical example taken from ActedBox. Now, I've already brought to the channel the walkthrough of the bashed machine, and in that machine at some point there was a cronjob exploitation. So what's the idea? Here I'm gonna start Kali, and in the history I believe, here I already have the machine. Essentially, for those who didn't see the walkthrough, I suggest to just go and check it out. Okay, but first I need to connect to the VPN. So here I connect to the VPN and then I'm able to access the history essentially. So let's go here. So the bash machine was this static site that contained a dev directory which exposed a web shell in PHP. So here we are executing in the context of www data. Here we can get essentially reverse shell payloads using pentestmonkey, testmonkey reverse shells, and we just need to change the IP. So we go into the Python is good enough, we copy it here, we paste it here. The only thing we need to change is the port 4321 and the IP. I'm gonna put the IP that I'm currently connected to the ActiveBox network. So in this case, it is the 10.10.10.10.14.21. So this one, I'm gonna put it here, essentially. So this is it. Now I'm gonna open a netcat listening on 4321. So notice here, I have a reverse shell. I'm gonna upgrade it with Python 3, import pty.spawn bin bash. And then I'm gonna do the same thing. However, since the sudo-l is vulnerable, because the sudo-l tells me that the user www-data can execute all commands as the user script manager. So this is a vulnerable sudo configuration. I can just do sudo-u script manager and then the same thing as the shell upgrade. And now I am script manager. At this point, the idea is to use the PSPY tool. So like here I can do export xterm and then I can clear. So the idea is to use the PSPY tool to enumerate the cronjobs. So how can we do it? Well, we've already downloaded the tool in our machine. So we go into TMP and we have this PSPY64. So the steps are enumerate the architecture to understand the binary that we need. So either 64 or 32. I can say you name A and look at this. x86 64, so we are a 64-bit machine. We can use PSPY64. We downloaded the binary into the attacker box, which we already did because it's in our Kali box. Then we transfer it from the attacker box to the victim machine. So I'm going to start a quick Python 3 server at port 1337. 1337, it's really important, this port. Cannot mistake this. And then in the victim machine, I'm going to do a wget HTTP. And then I put the IP address, which I already forgot, of my connection with ActiveBox. So I'm gonna put a new tab, EPA. So this is the EP 10.10.10.14.21. So here, essentially, 10.10.14.21, 1337, and then PSPY64. So I'm gonna get this. Notice this, I have the binary. And since this binary does not need external libraries, I can just execute it, PSPY64. I just do this and I execute it, PSPY64. Actually, before I'm gonna open a new tab because we're gonna need a new reverse shell here. So let's just spawn it right now because it's better. So here I have a new reverse shell, sudo script manager, Python 3, import pty.spawn bin bash. Okay, so let's execute PSPY in here and let's wait a bit to see the various processes that are executed on the victim machine. So at some point in the output of our PSPY, we notice that essentially it does this thing. It executes this command, it goes into the cd/scripts directory, and for every file that ends with a .py file, it's gonna do Python name of the file, and then it did a Python test.py. Also notice here the PID 1741 and the PID 1740. So first come the 40 and then the 41, and before those the 39, which is the cron daemon, essentially is the cron process. So the idea is that there is a cron job here that goes into the script directory and execute every script name that finishes its name with .py. So the folder here is cd/scripts, and for example there is this test.py which just open the test.txt. And so the idea is that all the scripts that are present in the /script folder, all the files that end with .py will be executed with Python. So this is the vulnerability of the cron job. How can we exploit it? Pretty simple. The idea is to create a reverse shell in Python and then expose it with an HTTP server. So let's get it, let's put it into the remote host, into the victim host. So this is my IP address, 1337 ref.py. And then here, I'm starting a netcat listener, and notice that thing, I already got a root shell. So now I can go into /root, I am root, who am I, id, host name. I can spawn a better shell, spawn bin bash, and stuff like that. So this is a practical exploitation, and all of this was possible because we executed PSPY and we were able to understand that there was this specific vulnerable cron job that executed all the script present in the /script directory. So that's the general idea. And so with this, we conclude this video. The tool here is PSPY, is extremely useful. It doesn't always work, of course. There's no guarantees, but most of the time this tool will be useful. You just run it on the background and read its output to understand what is going on in the system. And that's it for this video. I hope it was enjoyable. If it was so, leave some feedback in the comments and see you to the next video.